looking at the hardware accelerators. So, what is the need to have this hardware accelerators? Firstly, is the need for deep learning, AI, machine learning algorithms and networks. Nowadays, we have a lot of neural networks and a wide variety of ranges ranging from simple ANNs to convolutional neural network, then spiking neural networks, recurrent neural networks, oscillatory neural networks. So these neural networks are very complex in design as well as in calculation. And for the hardware implementation, what we require is we have a limited area. The area is limited. So from the hardware perspective, we have limited area, limited power, and we require some speed up. Like we require our calculations to uh, be completed in a particular time. So this is the constrained area which we have. Now let's start with a simple example. For example, I have a simple three-layer neural network. Three-layer neural network in the sense that to a fully connected neural network, right? That means I have input layer of neurons, then I have some hidden layer neurons, and then I have some output layer of neurons. And these are all fully connected. Fully connected means first neuron of this layer will be connected to each and every neuron of the second layer. Similarly, second neuron will be connected to all these layers, all these neurons. Similarly, each neuron of the second layer will have connections to every successive neuron. This is called a fully layered network. Now, this this is the weight matrix. Okay, the connections which are from here to here, these are the weights. So one weight matrix will be here, one weight matrix will be here. Now the from computation point of view, what we have is like the output from hidden layer. Output from hidden layer, how it is computed? It is computed by, let's output from hidden layer is HO. Okay, there will be a matrix which will be the product of weight matrix 1 and input from input vector of the on this. Whatever inputs we are giving here, this input vector multiplied by this weight matrix will give you output from this. Similarly, output from output layer. So here we will see OO will be the weight matrix W2 multiplied by H naught. Okay, so if we combine both these, what we will get is we will get as W2 into W1 into in. So these are the matrix vector multiplication, right? These are matrix vector multiplication, and again the result will be again having a matrix vector multiplication before we get a output vector. Now, if we want to have this on hardware, okay, we will have I, H, and O number of neurons and W1, W2, the weight matrix, that is synapse. These all need to be implemented on this hardware. The neurons will be here, synapses will be here. Now, on hardware, how do we implement it? We have a crossbar array. It is called a crossbar array with rows and columns, right? Now, each synapse is a connection between row and column. Each synapse is a connection between row and column. So for example, this is my first synapse. Let me draw it with some other color. We have this first synapse, second synapse, third synapse, fourth synapse, fifth synapse, sixth synapse, seventh synapse, and all these synapses are connected here, right? And from here we have I input vector. Let's say I0, I1, I2, I3, to the this, and here we will get the output. Here we will get the output H0, H1, H tuck. Okay. Again, these output will be the input for second layer. So again, we will have a crossbar here. These will be the input, and from here again we will have synapse. So here now we are getting inputs at vertical. So we can have output as, like from here we will get input, and we can connect our output from here, right? So this is the basic idea of hardware implementation of neural network, which is basically vector matrix multiplication, or we can say MAC operation. We will discuss this, we will have a discussion over it in detail in the next videos. Thank you.